rational equations, that means we're going to have an equal sign. So when we have an equal sign, we can use a special little math trick called fraction busting, meaning that when both sides of the equal sign, all the expressions, so this one has one expression on the left and two expressions on the right, when all of the expressions have the same, or what we call common denominator, then we can fraction bust. Yes. Yes, I will zoom in a little bit more. More. Okay. You're welcome. Oh. All right, so we're going to look at all of the expressions on both sides of the equal sign. See if we can find that common denominator. Common denominator looks like it's going to be 6k squared. Does everybody see how I got 6k squared? They all go evenly into 6k squared. On the left side of the equal sign, the expression already has 6k squared, so it doesn't need to be multiplied by anything. On the right side of the equal sign, our first expression has 3k squared in the denominator. So to get it to 6k squared, I need to multiply it by 2 over 2. And the second expression on the right side of the equal sign only has a k, so I need to multiply by 6k over 6k. Everybody with me so far? Yeah? Good? All right. Then we're going to, on the next line, we're going to write it with that common denominator. So the first one we just rewrote. Bring down that equal sign. In the numerator, we multiply 1 times 2. That should be super easy. That is over our new denominator of 6k squared. And then the second expression on the right, we multiply by 6k, which gets us 6k over that new denominator. This is where our fraction busting comes in. Now, since we have all the same denominator, we can use the fraction busting shortcut, and we just eliminate the denominators and set the numerators up as an equation. And then it looks like a super easy pre-algebra problem, right? Super easy pre-algebra problem. We just subtract 2 from both sides, which gets us negative 6k over equals negative 1. Divide both sides by the negative 6. And that simplifies to 1/6. All right. Any questions on number 1 there? Let's do one more together that's a little bit harder on this side, and then one on the back side as well. Anybody still writing? No? Okay. So I'm going to go down to number 7. I think that's about as big as we can go. All right, so the least common denominator for number 7 is v times v minus 5, which is also v squared minus 5v. So it's in factored form and distributed form, okay? So you'll either see it like this or like this. It's helpful to have it both if you can do that, okay? Why? Because you're going to notice that this expression and this expression already have the common denominator. So we only need to multiply this first expression by v minus 5 over v minus 5, okay? Then we have all the same denominator. 1 times v minus 5 is v minus 5. The other two expressions stay the same. Then we do our fraction busting. I didn't cross it out, but if it makes it easier for you, just cross it out. And then you rewrite the numerators as an equation. It looks super complicated, but it's really just a pre-algebra problem at this point. Okay, you're going to get your like terms together. I started to write an X there and it's a V, sorry. So V here and 1V here and 3 V's there, which is 4V. A negative 5 and a 12 is a 7. Then I want to get my variables on one side or the other. So I subtracted 7V from this side to move it over to this side. And I did this one in the same step. So 7 minus 7, which gets me negative 3V equal to negative 63. So divide both sides by negative 3, and we get V equals 21. All right, so for me, for number 17, just like for number 7 on the front, it was easiest and best to write the common denominator factored and not factored so that I could look at those denominators to see clearly what they needed to be multiplied by, okay? So obviously the first expression is good to go. The first expression after the equal sign, I needed to multiply by x minus 5 over x minus 5. And then the negative one, I needed to multiply by the whole thing, x squared minus 5x over x squared minus 5x. And for me, it was helpful to rewrite negative 1 as negative 1 over 1. You don't have to, but it just reminds me, okay, I need to multiply. So then you want to get everything with the same common denominator here. This one stays the same. This one gets FOILed out. This one just gets distributed out. Then we can fraction bust. And then we have to simplify a little bit. And you have to remember to distribute this negative sign. So if you have an x squared minus an x squared, you have no more x squareds, okay? And then if you have a 2x minus a negative 5x, you have a plus 7x.
No, because it's 2 minus negative 5.
I'm glad you knew what she was saying. Okay, good. All right. Then we just want to solve this easy pre-algebra problem at this point. Add 35 to both sides. Divide both sides by 7. And you end up with 36 over 7. You can change it to a decimal if you want. You could even change it to a mixed number, but sometimes it's just easiest to leave it as improper fraction.